So, last class we discussed about the what are different type of initiator under water method to use to increase testing efficiency. So today we are going to discuss about what is in the ZAG. So whenever we design the on transmission line, ZAG is very important. So that parameter we're going to find out here. Normally, see the diagram here. A is one of the tower, B is one of the tower, or pole. Can you say A pole and B pole? One conductor used here. So one conductor is connected with A and B. So total length of conductor is called as L. So from this diagram, how do you find out the sag? So see from point A to O, okay, that is called as sag. From conductor tower point A to B, this is called as span. From from lowest point of the conductor from O to ground, that is called as ground clearance. That's chlorine. So how to define the sag? So sag determine the difference in level between the point of the support and the support in the tower and the lowest point of conductor. This is called as sag. Span has been distance between the two tower A and B. That is called as span. So ground clearance has been difference in level between the lowest point of the conductor and the ground. That is called as ground clearance. Okay. Suppose if the sag is very small compared to the span, we get the parabolic shape. So whenever we can use this type of conductor, either that voltage level, either it may be equal voltage level or unequal voltage level. So, so, so with respect to two cases, we are going to find out the what are your forces, same by tension, a particular point. Either we assume by tangentially or horizontally. Yeah, horizontally. So first we are going to calculate what is the sag of the conductor with respect to the equal height with respect to tower A with respect to tower B. Here one conductor is connected with A and B here and total length of conductor L and also in half of one equal to L by 2, remaining half equal to L by 2. So from the conductor, we are assume the one point, particular point. For that point, we are going to calculate what the sag. That point we assume for either in nearest to A or center of the conductor or any point we assume. Now with the respective point, what's the sag? Okay. From the point we will take from O to B equal to X. Similarly, from B to B is called as sag. In horizontal position, we consider for X. In vertical, consider for Y. From O to B equal to X, yeah, half equal to X by 2. So based on this one, we are going with what's the tension or tension. Okay. That at a point O, okay, the point four, there are two forces will be act, okay, either horizontally or vertically. So correspondence equal to with respect to horizontal with respect to Y. So horizontal with respect to vertical, we have for Ty equal to W into X by 2. At a point A, at a point B, we know that X equal to L and Y equal to S. Okay. Now we are going to calculate the what sort of Z with respect to point P. That point P, okay, P S minus Y. S equal to, we know that S equal to W into L squared divided by 8 into T minus Y equal to W X squared divided by 2T. Suppose one for equal height voltage level sag point P equal to W by 80 into L square minus 4x. There are two forces back together. Okay, with respect to horizontal, with respect to vertical force. Okay, this is for equal height when we place the conductor here. For the case sag equal to W by 80 L square minus 4x square. Next, we are going to calculate for unequal height. Okay, what's the sag? Okay, see the diagram here. A is one of the tower, B is one of the. So normally this constitutes for mountain or hill station. For the case unequal height in the conductor. So total length of L from conductor A to O. This one of the sag. The conductor B to O. This one of the sag point S2. Okay. From we draw the line from horizontal line with respect to A. Okay. The distance equal to L. From lowest point to O to A. The distance equal to X1. We will take from O to B. That is equal to X2. So there are two sag for unequal height. We are going to get that there are two sag only S1, S2 there. Okay. Sn equal to with respect to x1 equal to W x1 by do t. Similarly, with respect to point, okay, with respect to point, sag 2 equal to W x2 squared by 2t. L is number total span length, T is nothing but tensor of the conductor, x1 nothing but distance point from O to A1. Nothing but x2 nothing but distance point from O to B there. Okay. S is number sag for highest tower, S1 is the highest lowest tower for A. So from this diagram, S1, S2 equal to S1 equal to W x1 by 2t, S2 equal to W x2 by 2t here. We need for total sag. So S2 minus S1. Here W x2 square by 2t minus W x1 by 2t. So suppose this we get answer equal to S equal to W by 2t, x minus x1 into L. So now that your S2 minus S1 equal to H, generally, okay, H equal to W by 2t, x minus x1 into L there. So from this one, x2 minus x1 equal to 2t h by WL. So 2x1 equal to 2x1 equal to L minus 2t h by WL. So finally, x1 equal to L by 2 minus t h by WL. X2 equal to L2 by t h plus WL. Okay. This is for suppose if the conductor is supported by unequal height, what that sag value. Okay. Next, we are going to write the suppose if the conductor will be ice coated. Okay, ice coated mean that okay. So ice coated mean that okay. What will happen in the conductor here? Okay, this one of the core. Here, this in middle of this one of the conductor. Around this one we can use the metal sheet. Diameter equal D, and also metal sheet equal to TD, and also thickness between the conductor and sheet equal to T. Okay. Suppose if the transmission is coated with ice, so T and thickness of the conductor and size of the increases. So that always thickness always depends upon the weather conditions. Okay. So the conditions. Okay. Here D is nothing but conductor diameter, T is nothing but thickness, ice coating thickness, D is nothing but overall diameter. So from this diagram, D equal to D plus 2T. Area of the conductor is this is circular one 5 by r square. So pi by 4 D square. So the here translation is I squared. So area of I squared equal to pi by 4 D square minus D square. So we find density of IC equal generally 915 kilogram meter square. So therefore total weight of IC equal to W equal to 915 into this one pi by 4 D square minus D square kilogram per meter square. So we are going at the vertical sag. Okay. Vertical sag formula equal to T plus dou T. So formula therefore W equal to D is known, 2D is known. We are going to substitute W equal to 915 into by 4 into D square plus 2T square minus D square. So we get the okay, W equal to finally get answer equal W equal to 915 into pi t into D plus T there. Okay. Suppose if the pressure will be changes, okay, due to the pressure, due to the wind pressure, how we are going to calculate the sag. Okay. So when you are going to apply the wind force of a conductor, so then wind force we assume that in horizontally, okay, horizontally. So for the case we are going to calculate the what is the value of forces. Okay, force. Okay, that force we have in terms of kilogram meter square. So dou equal to wind pressure into formula. Wind pressure of B here D plus dou T there. This is the projected surface area per unit length. Okay. This diagram is the combination of with respect to ice and wind for sag good formula equal WT into L square by ET, tan theta equal WW into W by W plus WI. Various is equal S cos theta. Okay. So what are the factors to be applied as sag? So one is for weight of the conductor, span, conductor sensing, ground clearance, and the temperature. So this raw parameter will be very, very important. Okay. So what the reason we are going to find a short. Okay. So if you know the tension, if you know the temperature, if you know the sag, we can draw the graph between the tension and temperature and sag temperature. We are going to calculate the performance. Okay. Okay. We are going to calculate the performance of the conductor. That's the reason we are going to study the string chart. So that graph can be represented here. So what are the parameter we are going consider connected sag template? So sag template is nothing but generally there are two type of tower used here. First one is for standard tower, then is for angle tower. Okay. Standard tower or angle tower. Okay. Standard tower, certain tower normally used for normal condition. Angle tower normally used for to withstand the loading. To withstand the loading. Okay. This is the table here. So how the use the conductor. If it is low level 0.4 kilowatt, span length equal to 80 meter, minimum ground equal 4.62, frame between base equal to 0.2. 11 kilowatt means that 100, minimum ground is equal to 4.6, frame between the base equal to 1.2. 30 kilowatt now, span length equal to 150 equal to 200, minimum ground is equal to 5.2. 66 kilowatt now, span length equal to we can use 200 to 300, minimum ground equal to 6.3. 130 kilowatt now, span equal to 350 equal to 360, minimum ground equal to 6.3, 350 the basic equal to 3.9. 220 kilowatt now, 360 equal to 380, minimum ground equal to 7.0, 350 the basic equal to 5.13. 400 kilowatt means that we can span equal to 400 volt, minimum ground equal to 8.8, clearance equal to 7.0. So based on this only we can use the sag template again. So up to this we will discuss about the what is simple sag. Okay, suppose if the conductor support equal height or unequal height, what's the name sag? Next we are going to get the suppose due to the ice coating, due to the wind pressure, how it will be varied. Last of it discuss about the what is the sag template. So what the reason we are going to study the sag template. Okay, so thank you.